Hey, it's Jesus Castillo from Ruby Guides, and in this video you are going to learn about the selection algorithm, the selection sorting algorithm in Ruby. Let's do this. Okay, so what's the selection sorting algorithm? Well, like the name says, it's an algorithm that allows you to sort a list. So in this case, I have an array of numbers, and of course you can list it with built-in methods like sort. So if I run sort, you get the sorted list, 1, 2, 3, 4, right? So that's sorted. But you might be wondering, how does this work? How is Ruby actually taking this list and producing the sorted list of numbers, right? Well, if you want to know that, learn more about how things work, about computer science, and all of that kind of fun stuff, then that's exactly what we're going to cover in this video. And specifically, the selection sort algorithm is one way to achieve the result of sorting the list. There are other ways like merge sort or bubble sort or quick sort, right? And every algorithm has different performance characteristics. Every algorithm is good for different things, and it's good to know different algorithms if you are interested in this topic of computer science, which, by the way, it might come up in some kind of interview question. So now let's get into the code. So right here I have the method. Of course, it's called selection sort. And what selection sort does is it finds the minimum. That's why it's called selection sort. It selects the smallest number and then it puts it into the front. It makes it the first number, and that's how the numbers become sorted, right? So for example, in this list, the smallest number is 1, right? So in this method that we're going to see in a moment, we're going to find 1, and then we're going to swap it with 2, right? And that's one round of sorting. And then we repeat this with the remaining numbers. So now we're going to ignore 1 because it's already sorted. And we're going to take the remaining and repeat the same operation. So it is going to be a loop. In fact, it's going to be a nested loop, a loop of loops, right? So if you are into computer science, this is a quadratic algorithm. It's written like this in the more formal notation. Is O of n squared, right? So that's the time complexity that we're dealing with for this method, for this algorithm. If you don't know what this means, then that's fine. I'm just giving this if you're already familiar with time complexity, and this is something that allows you to compare different algorithms. So you can tell, oh, this algorithm has this performance characteristic, and this other algorithm has this other one. Okay, so now the code, what you are waiting for. So here's the code. I'm going to be covering it piece by piece so you understand exactly what's going on. By the way, if you like this kind of video, make sure to click the thumbs up. The like button is like a thumbs up icon below this video. Click that so I know that you like this and some more people can find this video. Okay, so let's keep going. In here we have a loop. Specifically, we have an each loop, and we're going over a range from 0 to the list size. But notice that we have three dots, dot, 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 right? What does that mean? Well, the difference between 2 dots and 3 dots is that 3 dots excludes the end range. So what that means, in other words, is everything before the list size. So if the list size is 10, then it is everything until 9, right? So it's like we are removing 1, minus 1, when we use 3 dots. So that's why we have 3 dots in here and not 2, like in a regular range. So that's it for the loop. Now if I open this up, you're going to see a lot more code. So what's going on in here? Well, remember how I explained how selection works, that we're looking for a minimum? Well, that's what we do here. In this loop, we look for the minimum and we start from the remaining range. So this means the remaining range. So the remaining range is the whole list because we haven't sorted anything yet. The remaining range is this list, then this list, right? It becomes smaller and smaller and smaller until we are here and we are done. So that's why we have this range, which starts from the current index. And I call this left index because it's like the starting position, right? And then we have minimum index, which this we use in here. We use it to find where the position of the smallest number inside the array. And that happens like this, right? So we say that the minimum index is equal to n, the current number, if that number, the current number, is smaller than the number that we already have, okay? So the minimum index is the current index if the number stored at that index is smaller than the number that we already have, okay? So that's like the general idea for every minimum algorithm. We are just looking, is this number that we're looking at smaller than we already have? If so, then we store it. If not, when we ignore it and we check the next number. That's how we find the minimum. In this case, the minimum index instead of the minimum number. And why the minimum index, you might ask? Well, that's a great question. And here is why. We want the minimum index because we're going to swap. The next step in the selection sort algorithm is to swap the minimum value with the first value. So left index represents the first value in what's left of the array, of the list. So that's why we see it here. And min index represents the smallest number, the smallest number. So this is how you can do a swap in Ruby. You have the two things that you want to swap and you do equals and just swap the order. And that makes the swap in one step. In other languages, you have to have like a temporary variable and it's multiple steps, usually 3 steps. But in Ruby, you can do the swap in one step. So that's very nice, right? Remember to like this video if you like Ruby. So let's keep going. The last step after we swap is we repeat this, and we repeat this for every element of the list. So if the list is, in this case, 7 elements long, then we repeat this 7 times. And finally, we return the list. So let's see this working right here. You can see that it indeed is sorting. So we can see it's working. And by the way, if you are doing your own algorithms and your own code, make sure to test with more than one list, right? Because maybe it works with this list, but it doesn't work with other lists. So maybe if I add -1 and I add more numbers, maybe it's not exactly correct and that makes it not work. But in this case, when I change the list, it's still working, right? So remember to test with multiple inputs, with multiple lists in this case. So let's quickly review the steps of the selection algorithm in case this comes up during an interview, or maybe you want to take notes how this works. Step number 1, okay, is to find minimum. Step number 2 is to swap minimum with first number. And with first number, it means wherever we are in the remaining numbers, right? Because we keep decreasing the remaining numbers. And the first step is repeat with remaining numbers. So that's the selection sort algorithm. So a reminder, this is not a very efficient algorithm. You probably want to use Ruby's built-in algorithm. The point of this video is to help you see how it works so you can learn more about what Ruby is doing for you and the kind of things that go into a sorting algorithm. So that's it for this video. I hope you like it and learn something new. Please click the like button, the thumbs up button below this video so more people can find this video and benefit from it. That supports me and it helps me grow the channel and reach more learners like you. You want to learn more? Watch more videos in this channel right now. There are over 100 videos you can watch to improve your Ruby skills. Subscribe to the channel if you haven't yet, very important, so you don't miss videos, and click the notification bell, okay? And lastly, visit my website, rubyguides.com, rubyguides.com. Thanks a lot for your support, thanks a lot for watching. I will see you in the next video.